Hello. So today we are going to have a presentation of API. So this API is the connection between the Civil NX, Postman, Grasshopper, and Visual Studio Code. This API can get the request from one application. So this will be either Postman, Grasshopper, or VS Code as the input, and the processor will be the Civil NX, and the output will be either if you want to use Excel for the post-processing of results table, result image, or for the output you want to have the Civil NX as output. So you give the request in the Postman, Grasshopper, and VS Code as a Python language, and you get the results in Civil NX. I will, of course, further explain this in the next chapter. Okay, so in this slide, you can see that in order to use Python, this Python is important for the use of Visual Studio Code. So Visual Studio Code, as you can see in the bottom side here, this is the terminal of the Visual Studio Code. You can see that when I create a script of py3mpip install request, it means that I want to install a request script. So this request script is that the request to get an import request, so that every comment that you will give to the Python will be understood by the API, so that this request can be given to the Civil NX through the URL server. Okay, also you can see that you need to keep in mind that you need to click the add Python to path here. Okay, and also yeah, so the endpoints, yeah, okay, we will be go to the endpoints later. Okay, so in here, this can be seen in the Civil NX in the tools application ribbon. Okay, API setting disconnect plugin. So you can see in the REST API, we have base URL and MyPy. So base URL is basically just a URL server that the request will be housed in. So perhaps if you give a request, and this request will be given to the URL to be processed, and then the URL server will give to the appropriate output of application. So you can see this one is the endpoint. So you can use /users/post/comments here, and this is the URL. So the if it's combined, it will be like this: the URL plus the comments. So basically, the URL and MyPy is that the URL is the server and the MyPy is the password. So if you have maybe 5 engineers that are working in one model, all of those 5 engineers will have to use the same URL and the same MyPy, and they can access and collaborate to do the project simultaneously. So to do the project continually within each other. So you can see that the API key is a security string that grants authentication and access permission to developers or application using Web API. Okay. So this is the same as the last one, but this is just to emphasize the definition of the REST API. So REST API is a representational state transfer. So this is just like one of the architectural styles. But the important thing is that the request will use these four. So post, get, put, and delete. So post is just if you have nothing and you want to request something. So you make something out of nothing. So before you don't have anything, and after you create something, you use post. So the example is that maybe you create a nodes, you create an element, you create a section properties from Civil NX. So out of from nothing, no nodes whatsoever in the Civil NX, and you get the nodes in the Civil NX. And then for get is, for example, if you have a model, with a lot of complicated nodes, complicated section properties, complicated elastic link, complicated rigid link, for example, you can use get to obtain the script for that particular section. So if you want to see the script of section properties, for example, or the script of construction stage load, for example, you can use the code. Oh, sorry. You can use the URL, and you can use the endpoint. So the endpoint is the request of get, and then you can get the script of that particular section. So I will show you later. This is just the definition, the general definition of these two. And put is basically the same as post, but put is if you have something before and you want to replace it with another one. So maybe if you have a units, maybe you have a units of meter kilonewton and you want to change to millimeter newton, for example, you can use put. Or if you have a nodes and you want to change the nodes to something, you can use put again. So yeah. So post is creating something out of nothing, and put is replacing something from another thing. And delete is just delete. So keep in mind that if you are choosing delete, it means that if you have many options of your section, so maybe if you have maybe 10 section properties or 15 section properties, and you want to delete the section properties, you can use delete. But if you want to delete some of the section properties, you cannot delete some of it. So this delete command will delete all of things. Okay. So this API will be useful for workflow automation, interchangeable export of build models. So if you change your URL MAPI key, you can simultaneously fastly change your uh, your destination of a target, and then report interconnectivity. This one I will give you an example later. Okay. So this is the introduction of a Postman. So Postman is an application, a third-party application that will make it easier to access API. So you don't have to install Python, you don't have to install Visual Studio Code, so you don't have to create the raw script of a Python language in here. You just need to add the script, add sorry, not the script, add the data that you want to send. So for example, if you want to add a notes, just notes, you can just add the script of the notes. You don't need to add another basic script that is needed. So you can see here in the left side, this is the UI of the Postman. We can see collection, environment, flows, and history. So in the collection, so I will show you the okay. So this is the UI of this is the UI of the Postman here. So you can see there are collection, environment, flows, API, and history. So in this collection it means that you can create a collection here. You can click new here to create collection, and you can import your own collection. And in the data folder that I gave you, you can see in the you can just import from here these two. Okay, so this is the first collection. You can see that in this first collection, FCM general, so this one collection is to create the free cantilever method general uh, tutorial 5, I think, in the Civil NX. And you can see if I click here, this is save, this is run, this is fork. So this fork is just to like a duplicate the collection. And if you click run, you can see that I have sequenced the step from creating a new file, changing unit, changing structure type, creating nodes, creating material property, section property, element, creating element, um, and structure group, boundary group, load group, tenant group create until clicking the analysis button here. After save and then creating analysis button. So you can see if I do a split screen of a Civil NX with the Postman, I can create the automation between the Civil NX and Postman. Okay, so you can see here, this is the collection, right? And you can see in the right side here, top right side, it says that there is no environment. So how do we change that? Because this environment is important, because this environment can be located in the apps, API, and API setting here. So this no environment, you can see, you can click in here. This is the environment, and you can create something, create a new environment here. Click here. Or if you have created your environment, you can just click in your environment, and then you can copy the URL here. Copy the URL. Keep in mind you have to copy the same initial value and current value. Okay, so you have to copy the civil URL, map key, and JSON body. So you need to also make it the same. So in terms of the capital letter here, C, URL, etc. here, save, and you select the civil API here for the environment. Okay, why is it important? Because if you click on the collection here, and maybe you click on units, the two important thing for the collection is that body and headers. Okay, so body is just the JSON. So I will explain to you later this regarding this. And headers, if you click here, this means that uh, this is just the basic stuff if you are using Visual Studio Code using Python. But in the Postman, you don't need to use Python. So you just need to follow this basic stuff. So the important thing is that just the content type is the application slash JSON. And the second one that is important is the map key here. So this map key is not by default, so you need to add them before. So you can see I add the MAPI dash key here, and then this one, this is from environment. You can see here, if I hover my cursor here, I can see the environment that is given here, and you can see this is from environment. Okay, how do I do that? I just click I just type a double curly bracket here, and then after I click double curly bracket, I can see these three environments, or E. So this is from my environment. Okay, so if I click, because this is MIDAS, I click MIDAS here. So this is automatically becomes the automatically refers to the value of environment. This is also the same as the civil URL. You may remember that before, when I create a request, I need a URL plus the request. So this is the URL. So this is, as you can see, also environment, and then slash the request. So request is database/unit. How do I know this database? This database is located in the API manual here. If you just Google and you can search MIDAS API manual, and you can, after that you can click Civil NX JSON manual, and then for units you can just click project here, and then click unit system. You can see that the endpoint is db/units here, unit, and you can see that in every option here will show you, the first thing is the input URL. So of course the input URL is the base URL plus something/something. So this can be different between database and units. Okay, there are something that is post/doc, there is db/something, and etc. And the second one is the active methods. So this active methods is whether the request can handle a post, get, put, or delete. And this one is unit system, because unit system, no matter what project you use, you will always have the request of post, get, put, and delete, right? And sorry, so no matter what project that you use, you will always have a unit system. So there will always be a default unit system. So that's why you cannot use post, because you have something before, because you have default units. So the request that is available is only put, because you want to replace the units, or get, because you want to see what units that the unit system is using. Okay, so this one is the JSON schema. This is just a basic scheme, and usually the important thing is that you can click example here to see what is what here. The example. So you can see this one is a sign, this one is the ID, and this one is the value. And you can also see here, this is the option that can be created. So you can see there are required here or optional. Okay, and this is the data type, string here. Okay, okay, so after it is connected here, connect here, I can create something. So you can see here I have a units of kilonewton and meter, right? And if I want to change the units to Newton millimeter, after I use headers here, my key is the same, civil URL is the same. I change the body to Newton and millimeter, and I click send. Two things will be happening. The first thing is that the unit now become Newton and millimeter, just the same as this one. And the second one is the response is showing here that this code is complete, because you can see here this is the response of 200 OK. So it means that the server has responded as required. Okay, so going back to the first request here. So if I want to run this request, okay. So this request is from new, creating new. So if I click run here, yeah, it means that it will create a new file here. So in the left side, you can see that there are a information regarding the response time. So response time of creating new request here, you can see it's 14 seconds, and the other one is 0.6, 0.6 something here. Yep. So this is currently creating a attendant group. Span. Yeah, there is a problem with this one. I think this is because of my internet is not that good. So this is requiring me to save. So you can see this one is save copy, and then um, clicking the analysis button. Okay, so you can see um, the average response time is 3 seconds, but this 3 seconds is queued by the creating new copy, and then this one, I don't know why, this one is 29 seconds. Yeah, and this one is the, of course, this one is the analysis, because you can see the analysis time is 19 seconds and the analysis response time is 25 seconds, so there is a gap. Okay, you can see in the collection here, I have completed all of things: creating nodes, creating elements, span information, analysis for construction state analysis, analysis control data here, creating material properties, the time-dependent material here, etc., boundary, static load, and etc. here, tendon as well. Okay, so I will explain in details this one later. Okay. Okay, so that is for environment. Sorry. So that is for collection, and the second one is for environment. You can see this environment is the same, so you can just create the map, base URL, map key, and JSON body, and add it like before, the one that I shown you before, and then change the from here no environment to changing to your environment. So if you create your environment to Midas Open API, you can just click here to change to Midas Open API. Okay. So this one is the explanation of what it's called. So this code is called JSON. So JSON is a lightweight data of a text-based form that is easily understandable for people and machine. You can see that this is easily recognizable. So the RPSC is the comment. One is the sequence of the request, and this is the section manager for enforcement. So you can see if you click on the properties, section manager, and reinforcement here, and if you click on reinforcement, yes, in the support, uh, the option M bar J, option M bar I here is this one, and the shear reinforcement is the option of clicking either diagonal reinforcement, steel bar for web, torsional reinforcement, and etc. Here, yeah. This is for M bar, this is for S bar, yeah. So everything is located in the API manual and civil JSON manual here, there. So you can see which code that you need, and you can just edit based on what you need. Okay, so moving on, this one is the flows. So this is the third one of, sorry, the fourth one, but the API we don't touch this. So these flows here, this is actually the same as the running the collection from the collection, but this flows is making it more flexible because you can create sequences from other things. So you can create from one to the other, and you can also create an if logic. You can create. Okay, I will show you. So if you click on pause here, you can see that we are creating a start here, and then this is all of the requests that is available here. Okay, so how to create a new request? You can just click here. Okay, and then you can create an HTTP request. So this HTTP request is just same as the collection that you created. You create a flow module. You can, yeah, you can create a condition here to branch the data. You can create a logic if, yeah, and etc. So this one looping as well. So this one can be, the tutorial of this can be seen in the Postman tutorial. So you can just search uh, the FAQ of Postman to use all of the things here that can be uh, combined with your workflow. Yeah. Okay. So this is a video, so you can see uh, step by step to create the movable scaffolding system bridge from the flows to the Civil NX. So you can see it is starting creating the nodes, elements, and section properties. Yeah, and all of the works are created. So this one is the same as the last one I shown you. Yeah. Okay. And this one is just to emphasize the difference between a put, get, and delete and post here. To test API functionalities, we can open existing model, then using get method to get the JSON data from that model open. So maybe if the model is complicated, you can use get to get the JSON here. So maybe this one, if you want to create the DB node here for get, the body is nothing because get and delete doesn't have any body, but the one that is available is the response because get and delete is just an output driven data, but post and put needs something in the body. Okay. And this one is the introduction of Grasshopper. So you can see that Grasshopper is just a third-party application with Grasshopper functionality as workflow. You can see that in the Grasshopper we have a Rhino. So Rhino and Grasshopper is interchangeable. So Grasshopper is within Rhino. Grasshopper is like a plugin within Rhino. So um, the role of the MIDAS API here in Grasshopper is that the MIDAS Civil NX will replace the Grasshopper. So normally the Grasshopper, so in here you can see that the Grasshopper have a input like this. So this input is the number of something. So maybe if this one is the maybe the section properties of a girder, and you change the number slider here, you can just change the number slider and the data will automatically change because of the input change in the Grasshopper. So if you add the API in the Grasshopper, it will change the value in the Rhino. And if you create an API, you create a base URL and map key in here. This is already created, so I will explain you later regarding this. It will automatically change in the Civil NX. So I will show you the example later. This is just an introduction. Okay. And this one is regarding the automatic number and attribute value generation for Civil NX. And you can also create the post analysis here to create the results. And this one is the same. So the Grasshopper is actually the same as the Postman and also the same as Visual Studio Code, because both of them, all of them are using JSON. But the difference is that if Visual Studio Code is using Python um, in the raw in the raw um, in the raw model, so you can see all of the basic stuff of Python, and you can also see the basic JSON. In the Postman, you only show the JSON code, and in the Grasshopper, you can only see this one. This is like the plugin from the Grasshopper. So this plugin from the Grasshopper, you can see in the left side, they have a lot of inputs here. And this is the software. So you can input the key, input the section name, you can input the shape, material, offset, and option here. And the right side is the output. So if you if you create something in the key, segment, and etc., and you create a panel. So this panel is just like a view, to view the codes that is generated. So for example, in the right side here, you can see the created section. The created section of a section name, main girder, section type, composite, etc. with the shape of this one. Okay. So this one is equivalent to the right hand side here, the section data here. So the Midas GH, you can see here, this Midas GH is a plugin that is developed by our headquarter. So they have developed the JSON, and they have inputted this JSON to this plugin in the left. And if you input something in the plugin, it will yielded this one, this files, this data. Okay. Later I will show you about the example. Okay. So this one is just to show you the capability of Rhino-Grasshopper. This is just integration of calculation and data management function. User can adjust parameter value and organize data without needing different applications. So this is all of these are within one application. And this is the data that is available in the Grasshopper. You can create using integer and real data. You can use a string data. Of course, string is just a number, array, and select if you have a drop-down menu like this. Object is to create the shape component of DB, tapered, user, PSC, SRC, and composite like this. So this is section component like before, but the shape you can create something out of the option like this. And this Midas GH is just the plugin that has been created by our developer. Okay, so this one is the Excel connector. So Excel connector is or Midas connector in Microsoft Excel is just a post analysis tools to create real-time updates, grouping system, and fast post analysis results. So if you have maybe a model in the Civil NX and you want to link the output of those NX into the Midas connector, you can do so. So you can just input your Civil NX. Sorry, you can just connect your model in the Civil NX, and you can connect it to the Excel. And every time you update something in your Civil NX and you click update, all of the data in the Excel will change depending on your actual results in the Civil NX. Okay, so you can see here we have a different folder. So this is the second part here, the grouping system. So maybe if you have many analysis results, so maybe analysis result for beam force, analysis results for reaction, deformation, you can create separate group and you can just update some of the group. So maybe if you only change the support maybe, and you want to see the change in deformation, you can just update the deformation. You don't need to update the beam force and etc. This will save time for your convenience. Okay, and this one is a Visual Basic Excel on API. So this one is important if you have maybe a repetitive model. So maybe you have a connection strengthening problem in your bridge, for example. So maybe within your bridge, you need a repetitive model to create your own customization of your Visual Basic. So yeah, you can use Visual Basic. So all of this is just an introduction. You can see chapter 2 will be hands-on experience, but this chapter 1 is just an introduction. Okay, so you don't need to worry about it. Okay, so we move on to the chapter 2. Okay, this chapter 2 is the first thing first is that we will be touching of Midas API with Visual Basic. Okay, so this Midas API with Visual Basic is basically the same. So this is just um, an actual scripting of a code with a Midas Civil NX. Okay. So this is the same as I said before. The important thing of the headers that is in the Postman. So if you remember when I use in the collection here in the headers, the important thing is that only the content type and the map key. That's why also the URL, of course, because the URL is this one. So the important thing is that the URL here, the MAPI key, and the headers. So the headers is only, the important thing is that the content type here is the application application slash JSON, and the MAPI key equals MAPI key here. So this is just to, because this is just to declare the variable that you have. So this variable is this one, and this one is to show you that the MAPI key should use the variable MAPI key that is already declared in here. Okay. So this one I just want to make sure that the MAPI key is the same. Just copy here and paste. Okay. Okay. So if I click run here, yeah, you can see that this is already creating a new file. Create a new file, changing unit system, um, yeah, creating nodes, creating elements here, boundary group, structure group, load group. Um, yeah, you can see in the cursor here, this is still working, so you cannot interrupt anything in the Civil NX. This is still working. So the important thing is that you know the sequence of what to do. So in here, the sequence is to create a new structure type and etc. like this. So this is not important, the how to create this one, because this one is available in the this one is available in your API manual. Okay, so you don't need to. Okay, so this one is creating the second one because I clicked twice. You can see this is the first time I click, and this is the second time I clicked there. So this is repeating from what I did before. Okay, so in the structure group, you can see this is just to create the structure group, and this is the creating peer here, peer one. Yep. And this is the element list. Okay, so this one is the structure group. You can see the group in here, structure group. So peer one here you can see, and this is boundary group. Boundary group is the PNGR here. This is load group here, LDGR here, and tenant, yeah, tenant group is nothing. Yeah, because in here I do not create any tenant group. I only create the section load structure group, boundary group, and load group. Yep. But in my Postman, I create the tenant group. Okay. So that's why this is the depending on your sequences. Okay. Okay, so this one is just to emphasize that if you use Postman, you can see the response time. This is the run results. So if you run something and you see the response time, so maybe you can optimize the request so that you have much shorter response time. Okay, and this one is just the sequences of how do I create the Postman. So how do I create the Postman? It's just from creating a document new here with the body of like this with the headers. Of course, all of the headers will be the same. So you are using application.json for content type and etc. Because as you can see in my Visual Studio Code, all of the headers, so this is all of the headers are the same. So every request in here will use these headers and this alone. So you can see in my request here, Visual Studio Code, you can see if I use request post, request.post, open bracket URL, so URL is just the civil URL here, plus you have to remember if you use string, so this is string, you need to use apostrophe like this, string doc slash new here, and then headers equals headers. So this is just to call the headers part here in the headers, and JSON is this one. Okay, and keep in mind that because this is a Python script, so you have to create the comment, yeah, the comment like this in the same exact capital letter. So if you click on doc and new, you have to use capital letter in this one. But if you use Postman, because this Postman doesn't need any Python, so you can just use small small letter. That's okay. 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 So moving on. This one is creating structure type, creating nodes, creating element here, and then this is creating a structure group, boundary group, load group, and span information. Okay. So you can see this is all for the structure group. I do not include the tenant group because this tenant group will be grouped to the creation of the tenant later. Okay, so this is only shown you the structure group, boundary group, and load group. And this one is for material section and material properties and section properties. So this one is material properties. This one is section properties. This is the tendon and shrinkage here. 1, 2, 3, 4. This is change property. This is a tendon material length. This is a tendon material compressive strength, and this is tendon material creep and shrinkage. Yep. So all of these are in the API manual JSON, Civil NX JSON. Yep. And this is the one that is for tendon properties. So the left side is the tendon group, and this is a tendon profile. Yeah, tendon profile, and this is the tendon pre-stress. Yeah, and this is also the tendon load. Yeah, I think this one is the tendon. You can see in the load pre-stress here. This is the tenant property, and this is tenant profile, and this is tenant pre-stress. So this is the loading. So 1, 2 is the properties, this is the group, this is the loading of that pre-stress. Okay, so this is just a boundary. So you create the support, you create the elastic link, and you create the rigid link. This one is the load case for static. So this one is a static load case. This one is a self-wake. This one is nodal loads, and this one is the beam loads. This one is for construction stage load, and this one is a time load for construction stage. Yep. So if you click on API manual here, you can see that all of these are already grouped. So this is node element, node elm skew here, and this is properties, material, TDMF, TDMT, TDME, DMP here. This is the one that I used before. This is a boundary for cons. This is a constraint support for support here, and elastic link, rigid link here. If you use general link, beam and release, you can use this one. Static load for the static load case, self-wake, nodal loads, and beam loads here. Pre-stress, tenant property, tenant profile here, and construction stage loads. This is to define construction stage and time loads for construction stage. Okay. And this one is for analysis. The analysis this is the main control analysis. So this is just a general option for the analysis. And this one is analysis for construction stage. So this one is analysis for main control data. This is the first one, the ATCT, and the second one is the construction stage here. Okay, and this one is the load combination. Yep. So you can see that this load combination is creating this one, yeah, GLCP 1, 2, 3, 4, 5, 6 here, and envelope. And also, I want to show you something. So if I use Postman like this, and I want to change something, so from lcom gen like this, okay, okay, I will show you. Okay, so if I delete, okay, so maybe I will use get this first. Okay, to copy, I think this is the same. This is the 8. This is 8. Okay, and maybe I use delete. So you can see that in the right side it is deleted. Okay, and maybe I want to use post again to create another one. So if I use post, so maybe I use post here, and I want to change the load combination using put right here, and I want to change maybe the GLCP1 into GLCP11, for example. I want to click send. I cannot do this. Why? Because I have number 7 and number 8 in here. Why? Because number 7 and number 8 has an envelope. So this load combination has another load combination. So this is like a stacked version of load combination. So you cannot do this. So you have to delete this one first, and you have to post something without envelope. So maybe I just post 1 until 6. So I don't need to post another. Yeah. So this is until 6, right? So if I click post here, I only create the 1 until 6 without envelope, right? And if I want to change this, maybe GLCP11 here into GLCP1, I can do it. Why? Because there's no envelope. There's no stack load combination. Okay. So for you to change your own LCOM gen, you can use without envelope, or if you have to use envelope, you can just delete first and then post another one. So you cannot use put if you have envelope. So you just use delete first and then you post another one. Okay. Okay, for this one, this is just to show you the collection. You can create some collection and you can use some collection here, and then you can create the sequence like this. Okay, so you can change the sequence. Okay, like this. So you can maybe add another one. So if you have something maybe in here, maybe you want to click here. So if you have something, maybe you have close here, close request, and you want to add the close request in the last one, you can just drag and drop in here. Okay, so this will automatically, yeah. Okay. This one is the second one. This one is regarding Grasshopper. Okay. 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 So let us open Rhino. So this model this model is a simple frame model. Okay. So this is just a simple frame model. This is similar to tutorial 2, I think, for Civil NX. Okay. So you can open your Rhino here, and you can click here, Grasshopper, or if you cannot see any tools in here, you can just click tools. Sorry, you can use click Windows and toolbars, and you can take this one. So usually the default part is that this is like this. So only file and there's no toolbar. And if you click Windows and toolbars and you check this one, you will see this toolbar. Or if you don't want to use toolbar, you can just click in the comment here and just type Grasshopper. This will show you, this will create the application of the Grasshopper. Okay, so for this one, we will be creating the okay. So this is the Rhino and Grasshopper. So if you want to move your cursor, you can just right click in the um, right right mouse button, and you can just drag. Yeah, you can just click here to move the camera. Okay, so in here you can just, if you want to see the whole perspective things, you can just click here and click maximize. Okay, so you can see in the right side, this is the comment, and the left side, is the file, and I want to explain to you about the Rhino and Grasshopper first, and then after that we will move on to the connection between the Grasshopper and Civil NX. Okay. So here is the sequences of the simple frame model. You can see here, if I click here, I can see that the rectangular is created. Okay, maybe I will do a simple stuff first. Okay, say you want to create a curve in the Rhino. Maybe you click here, you click curve here, and you create a 3-degree curve. So maybe 1, this is 2, the second one is the radius, and 3, maybe this one. And enter, click enter. Okay, so you can see here you can see there are points here, right? So if I click this point, you can see in the left side there are points that is connected to the point in the grasshopper. Okay, so if I double click here and I click curve, you can see that in this curve there is a warning error message. It says floating parameter CR curve failed to collect data. So this curve is not connected to any of the curve in the Rhino. So how do I connect that? I just right click here and click set one curve, and I select this curve. Okay. So if I click this point is selected, and if I click the curve, this curve is selected. Okay. So I want to show you the wonder of Grasshopper from the curve. Okay, so if I click curve, if I click divide curve here, so this one is the C is the curve, N is the number, the count of the number. Okay, so if I connect this curve to this curve, you can see that this is already divided. But how do I determine the number of dividing in here? How do I do that? I just click number slider here. Okay, and I double click this one, the one that is darker, and then I change the number to 10 with the digits of 0. Okay, so I can just slide the number here, and I maybe just connect to N here. So if I slide the number, you can see that the defined number is shown here. Okay. So this is just to show you the wonder of Rhino-Grasshopper. Okay, I want to show you as well. This is the call index. So call index is just a okay, maybe I will go with the frame first before I go to call index. Okay. Okay, so when I click point here, I see the point here, and I want to create a plane. So this plane is only X and Y. So this is the plane is only in this direction and in this direction. So there's no plane in the Z direction, because this one is only 2D. Okay, so this is only origin and this is plane. So that's why when I click this one, I cannot see anything, because this is only the request. And if I click here for rectangular, I can see the shape. Okay, so what what is the rectangular's needs? So the rectangular needs is that the first is the plane. So this plane is just an imaginary stuff because this is only the point and this is only the xy plane. So this xy plane is just the direction of the plane's direction. So that's why when I click this one, this is just a direction. So there's no point in here. And the rectangular needs the x direction and y direction sizes. So you can see in the x direction, if I change this x direction, you can see that this is connected. Also for y direction, you can see it will move to the left side and the right side here. And the extend x and extend y is just the times it multiply. In x direction, you can see it multiplies to 2 and 3 and 4 here, 1. And for the y, it also multiply because this is y in one direction. You can see it multiply until 10 here. And that's why this is only x and y. So no matter what extent and what distance you gave, it will only grow in x and y direction. There is no movement in the z direction. That's why we need another one in the z direction. This is to create a unit z. So this is similar as this one. This is only the direction. So this is the distance and this is the factor of the unit direction. So this in z direction. And this one is the creation of that original point. So the original point is in the x and y direction. So you can see here, this is the geometry of this one, 1, 2, 3, 4, 5, 6, and the motion is in z direction. So this geometry is in the bottom and the motion is in the z direction of three units here, and that's why this is creating this one. Okay, to show you easy, to make it easier, you can just click panel here and you can see here. So you can see that in the rectangular, the points is the 0, 0, 0 and 0, 4.5 and 0 here. Okay. And if we click in the unit vector here, you can see that the unit vector is only 0, 0, 3 because this is only z direction. So this is 3. Okay. Okay. So this one, you already know that this one is the copy paste from the bottom here. Okay. And you can see that from this geometry, it inputs a lot of things, right? From the point, this is the point of this, the bottom here, and this is the point from the top. Okay, so we want to create the line that connects between the bottom and the top. So that's why we have this one line. One line, this is start point from the top, from the bottom, and the end point is the point from the top. Okay, and this is where the call index is. Okay, I will show you with multiple panel. Okay, so what is list length? So list length is just information of how many numbers there is in one coordinates. So you can see in here in the geometry, we in one coordinates we have 2, in another coordinates we have 2 as well. So we will have this panel of list length to be 2 for each coordinates, right? Because this is just a 1 and 2, 1 and 2, 1 and 2. like this. So this list length is just to know number of coordinates that is in there. Okay, so this call index is to remove the number of the number of indexes that is in that list. Okay. Okay, let me show you. You can see here, the first thing is this one. The first, before call index, you have the coordinate 0 and coordinate 1 with a 003 and 04.53. And you have the minus. The minus is the this list length, because you can see this indices is the culling indices. So this will remove the indices. So if you have this indices of 2, it means that from this one, it will delete the second coordinates. Okay. So you can see from this one, 1, 2, 3, 4, 5, 6. Okay. With the call index, it will remove the second coordinates. Okay. So you can see from the 003 is this one, 04.53 is this one, 7.6403, 7.64.53, and this is 15.203 and 15.24.53, this one. And for the list length, you will delete the second one. So you will delete this one, 1, 2, 3, and the results is this one, the first part, 1, 2, 3. Okay, so that's why in the first one is this one, and the shift list is that offset all items in the list. So the shift list is just the list plus 1. So if the call index is to remove the second one with the list length here, because the list length, so if you have two numbers in each coordinates and you use list length as a minus for the call index, it will remove the second index. So if you have 3 index, for example, maybe if in here you have 3 number in each of the coordinates and you use list length, you will remove the third indexes. Okay, so this is depends on the number of your indexes. Okay, so for the call index, you will have 1 here, 003, 7.603, and 15.203. And for the shift list, you will have the 7.64.53. Sorry, you will have the 4.53 here for this one, and 7.64.53 and 15.24.53. Okay, so this basically call index and shift list is just to divide the two, between the two. So this is to show you that if you have only 2 indexes in one coordinates, this will be simple, because call index is basically just like the half stuff, and the shift list is the other half. So you can see that this one is connecting to this one is just the same as this one. But if you have maybe 3 indexes, this will be hard, because the call index, you will have 1 and 2 for the indexes, and the shift list you will have 3, the number 3. Okay, so yeah. And then if you have this one for the last one and this one for the first one, and this line will be connecting between the first one and the last one, yeah, like this. Okay, so this is for creating the line, the first line and the second line. And for the third line, This one is a flip matrix. So flip matrix is just the same. So maybe if you have maybe if you have this one 003 04.53 here, and if you flip the matrix, for example, you will have, so maybe this one, the coordinate 1 has 003 04.53, and now it will have, the coordinate 1 will have 003 7.603 15.203. So it's basically just flipping the x and y coordinates. Okay, so maybe the second coordinate will have 04.53, 7.64.53, and 15.24.53. You can see here. So the previous one you have three coordinates, and the second flip matrix you have only two coordinates. So this is basically just flipping stuff. After flipping stuff, you create the list length again. So this list length will be 3. For each one. So it will delete the third part. So from 003, 7.6, and 15.2, it will delete the 15.2 part to become like this. And the shift list will be the one that is after the first coordinates. So you can see in the shift list 1, 2, 3, 4, and the call index 1, 2, 3, 4. Sorry, the call index will be 1, 2, 3, 4, and the shift list will be 3, 4, 5, 6. Yeah, this one is not important because you can see that in the start point, even if you have 4 start point here, you don't need to have 2 start point, because if you have 4 start point, this is just like continuing to one to the other. So you don't need to only have 2 points. You can have as many as you want, as long as this point is perpendicular to each other. Yeah. And this is the divide curve. The count is, yeah, you can use count here. So if you change the count, it will have many number here. So maybe you use 3 or 4. Yeah. Okay. Yeah, because you have many points in the call index and shift list, you need to have a polyline, because you have multiple points that is connecting a single line. Okay, and then this one is to connect between the point and the line. Yeah, and this one is the same. Yeah, using shift list, call index, shift paths, and flip matrix. Yeah. Okay, so this one you have, because you can see in here you have the points that is created, but without the rectangular, because this rectangular is different, because this rectangular is the original lines, and it is connected to here. Okay, so this is considered as shape, sorry, because as line in the pin. Okay, so here you can see that how do I get this one and etc. This one is created from Midas GH. So this is the Midas GH here. So these tools can be found in if you search maybe Midas GH food for Rhino, and then you click here. Here. And then after that you have to log in here, and then you can download the Midas GH by Midas IT. Download, and you can, because this is constantly updated, you can just click install here depending on your platform, Rhino 8 or Rhino 7. When you click install, you can see in the Grasshopper here, it will automatically show you the package manager, and you can just install, click install here. I already installed it, so I don't need to install it again. And yeah, so if you don't want to search one by one in here, of course you can use the Midas API online manual here to see the Civil NX and Grasshopper. You click here, and you can see this is the explanation of different tools here: Midas cat node, Midas setting, structure groups, nodes, beam, element, etc. here. So if you don't want to find um, which one is beam, so for example, if you have maybe in the properties you don't know which one, compressive, concrete material, grip shrinkage here, but this beam is located in the node and element. You can click in here, beam. But if you don't want to know, if you don't want to search one by one, you can just double click and you can just search beam. It will automatically be here. And they will ask you about the node number, material ID, section name, etc., section ID and line, etc. So this, all of the things that we created here is belongs to the line here, and this is section ID. So the section ID is just when you create the shape database here. This shape database is the section properties. So this is in here, in whether when you create the shape DB here, span information, this one. This is to create the node local axis. This is the tenant group. So if you don't want to search, you can just, yeah. ShapeDB has some of the drop-down menu. You can see if you want to have a value, the shape, and the code here. And the section name. Yeah. Okay. And you can see the section name. You can just create a panel like this. Yeah. And if you have many shape database, you can just use merge here to combine all of the database. Okay. So this is for a section property. You can also change offset here. This offset is a center and center top here. This is based on the section property. And this one is a material. If you use still material, you can use drop down menu here. So this one is only for Grasshopper, right? Rhino and Grasshopper. So if you want to connect the Rhino and Civil NX, you first need to click here, Midas setting. Okay, this Midas setting, this is the same as the last one, so you can just click API here and click copy, and you can just paste the URL and paste the password. Okay, you can see that previously it's a red, but right now it's gray. So it means that this is already connected. So you don't need to connect this one to anything, because when you use the Midas setting here, it will automatically be connected. Okay, so when I click run, so because this one has many things. So this is steel material, this is section property, this is the actual creating the beam element and node. So if I want to click maybe just here to create the steel material, you can see here that I have created the steel material here, SS275. It is not assigned yet because there is no node element or anything. And if I want to maybe change the number slider to maybe 3, 4, for example, and change the name to hello, for example, and maybe change the standard name, to CNS06, SS400, for example. When I click run, yeah, you can see the previous one is already there and the hello is already here. So you can just click here if you want to delete. Yeah. So previously, if you want to delete the SS275, you can just click and delete that. Okay. And this is the same as creating the section property here. Yep. You can also delete. Okay. So when you click run here, you can just click run, and it will automatically create the node element, create the material. Um, yeah, actually I changed something, so maybe. Same node. Yeah. Okay. Okay. So this one is just to emphasize to connect between the base URL and the map key. You need to use the MIDAS setting that is seen in the left side there, in the top left side, and you need to input the base URL and map key. And then this is the one that is the property of each of the number slider. So you can change the decimal number in here, and you can change the maximum and minimum number in here. Okay. And this one, so this one is the same as the last one. So when you have a sequence of points and you use list length, because as I said before, the list length is not a point, but list length is an integer. So the list length is the number of data that is in the coordinates, and the list length, for example, the list length is number 3, because you can see here the list length is 3. For example, the first coordinate is 3, the second coordinate is 3, the third coordinate is 3, for example. And you cannot use that 3 as a start point, because the 3 is only one number, but the start point that is needed here is supposed to be coordinates. So that's why if you have the list length, you need to call the list length first and then have the other data that is the actual data. So this actual data is maybe 3 coordinates, and you have a list length of number 3. So it means that the call index output will be only 2 coordinates. That's why in the 2 coordinates can be indicated as a start point, and the shift list, that is the first coordinates plus 1, can be attributed as the endpoint. So start point and end point. And then after that we have line, and line we go curve to become point, like this. After point and then polyline, because we have multiple points that is being going through with the line, so that's why we need to polyline. Okay. So this one is the grasshopper part of creating the section property and material section. Material properties. There's a drop-down menu here, and you can double click to see which one. And this one is the results. So you can see that after creating the simple frame model, after creating the model and changing the material properties and changing the section properties, you get the shape with the section properties assigned, material properties assigned, elements assigned. Elements is connected to the nodes. Okay. This one is just the plugins. So the plugins usually is to make it easier for you to get the response spectrum. So you in the Civil NX you have a plugin. So if you click on apps here and you can click on plugins, you can see that in the plugins you have many marketplace here. This marketplace have the amount of plugins that you can choose. So from the alignment generator, the local axis, the tendon profile here, and in this case, this will be the response spectrum generator. Here. So usually there is a video to guide you on how to do it. Yeah, so this is the same as to create a load from the dynamic loads here to create the response spectrum function here. But the difference is that this one is a real time changing. So if you maybe change here and you change the subsoil classes, you can see that it is in real time changing, and you can also change the factor and it will automatically changing based on your input. Okay, so this one is faster than before. So you have a lot of option to see, and you can also create your own plugin. So this is based on Node.js. Everything you need to know can be accessed in the plugin online manual here. This is introduction, how to use it, and guide if you want to write a Python code, and guide to create a plugin for developers here. And in the bottom, you can see already created a plugin item here for you to choose. Okay, and this one is a Midas connector. So I will show you how to connect the Midas connector. Okay. So if you have the Civil NX, for example, here, maybe you have a FCM general, and you want to analyze, for example, yeah, it's already analyzed. Okay, so the first thing first that you want to do is that to install the Midas connector. If you have not your Midas, if you haven't get any of your Midas connector, you can just click here and you can search Midas connector. Okay, so when you have those Midas connector, usually we similar as Midas GH, you can just search for Midas connector Excel. Usually, you can see that in here. This is like the app store for Microsoft here, and you can just click at it now, and it will be referred to your Excel account. Okay, so after you have that, you can just click here, and it will ask you for the data importer, the connection, automation, and customization. This is just the function that the MIDAS connector has. You can just click here to continue, and they will ask you for your permission to use your account as the MIDAS connector authorization. Okay, so when you see this one, the circle with the red color, you can just click here, and you can click on the API to see, to copy the MAPI key here. So you just copy the MAPI key and click check. Okay, so you can see that API key is valid. You can just apply, and from the red it turns green. Okay, so how to create your report? Okay, so you can just simply click results here. This is for maybe results these tables. You want to see the reaction, for example, GLCP1. You can click OK. You can right click and you can click dynamic report table. Okay, you can just name your names. Maybe React G is okay, and you can click on the report here, and you can click on the user defined tables. So previously I have reaction 1, bforce 1, displacement G, and reaction G. Okay, so all of this, because this is already created, is automatically shown in here. You can see the React G is created last. So you can see that previously is only reaction 1, bforce 1, displacement G, right? And React G is updated after that. So what we want to do is that we click on the tables that we want to place our table in. Click here, and then just click here and click OK. And for example, we want to use the React G here with maybe you want to create a folder. So you have two options. You have to create your own folder, or you want to use default as a folder. So this one is, as I said before, this one is for grouping. So if you have, for example, React G, you want to create your own folder, maybe reaction, you click here to add folder, and then you add the folder. So it means that you have two different folder. The first one is only for reaction, and maybe for the other one, for the bforce, you want to add to your default, you can add the folder. Okay, why can I use the A1 here? Because A1 is already for reaction. So maybe you want to change it to 10 here and add to folder. So you can see the bforce one is in A10, React G is in A1. So you can see that the React G is only 6 lines, or maybe 8 with the table head here. So this is safe because maybe React G only takes this table, these spaces, and maybe the bforce will take from this space. Okay, so maybe for displacement, sorry, you want to see maybe in the J1 here. Okay, so you can just all table import and update. Okay, so J is wrong because you can see J1 is intersected with another bforce one. So maybe you change J1 to maybe L1. Or you can maybe edit it L1, and you can just update this one. Okay, you can see that the L1 is already here. Okay, so when I say group, I can only update some of the groups. So maybe this one, if I have reaction here, I can only update the reaction. So I just click here and I click here to update only the reaction. Or if I only want to update one of the tables, like I said before, I just click here and click here. So maybe if you have lots of tables, you don't need to click, you don't need to, when you, every time you change something in the data, you don't need to click all table import and update. So it will take long time if you always click all table import and update. So this is the same as results image. Okay. So if you have in here, we already have user defined image for only reaction pick one here. So if you click reaction pick one, A1, yeah, you can see. Yeah. This one is wrong. The view is not correct because this is not yet corrected. So maybe you can just delete this one first, and then maybe result display, reaction forces for F, X, Y, Z here, maybe with a value, maybe value with a min max only, and you can just right click and dynamic report image and react here. Okay, so when you click OK, you can see user defined image is already here. You can see that it's updated. Just select list, react. Yeah, you can see because this one doesn't have any legend, so yeah, there is no legend in here. Okay. Yeah, you can see here in the dynamic report image for result image, you can right click in dynamic report image and then change the name, and it will show in the MIDAS connector. And this is for results table. And this one is API for Visual Basic Excel. So in the right side, you can see that this is the macro UI. So macro means that we have a button that is assigned to a code, a script. So you can see in here I have two buttons here, and that's why I have two codes. Okay, I will show you. Okay, so this one is to create a simple PSC, still box with a PSC on top. So you can see here, this is for the girder, in the bottom, and the PSC here. This is for the top side of the girder. Okay. So in the top side of the girder, I want to create a customized beam. Customized PSC box. P, uh, sorry, customized PSC. Yeah, customized PSC like this. You can see that it has a lot of coordinates, right? So in my Visual Basic, I will have a button to create a new file, a button to create the model, and a button to analysis. So this one and this one is simple because this is just a doc anal and this one is doc new. If you remember in your Postman exercise earlier, so yeah, and this is to create the whole thing. So this one is to change the unit, this one is to create the section, and this one is the length of the node. This is the name of the section. This is the creation of the section ID, material ID, node creation here, and this is the section properties. Yeah, this is the coordinates for the PSC. Okay. This one is for material concrete. This one is for loading. This one is for load combination. Okay. You can see it here in the data. You can see there are Visual Basic and there are macro. So if you click on macro, I have 3 buttons that is assigned to each of the macro here. Analysis, create symbol beam, and new file. New file is this one. This one is create symbol beam. This one is analysis. Okay, when I click Visual Basic, it will show you the analysis, create symbol beam, and new file, and web request. So web request is basically just the same as a Visual Studio Code, but the top side of the Visual Studio Code. So this is just a to add the base URL, the map key, and etc. And also content type like this, application JSON, the map key here, body. Yeah, this one is a basic stuff. So you just if you want to create this one, you can just copy this one and yeah. But the different part is that I have this base URL and map key here, base URL and map key within the data, within the cell in the Excel. So you can see base URL is cell J15. So this is J15. So this one is the base URL, and this one is the map key J16. So this one cells 16J value. Okay. Okay. So web request is okay, and new file is also the same. We create a sub new file and then we declare the str command as string, str body as string, and str json new as string. So this one we just the command is doc new, the str body. This is the same as the json body in the Postman, and this is the json new is equal web request post comma str comments str body. So yeah, this is basically the same as the Postman. So maybe I will show you maybe side by side. So this is this is the same new and new here. Doc new with the civil URL is the page URL. The str body is the JSON on the body here, JSON body, and the JSON new is the web request using post, comment, and body. Yeah, so that's basically it. Also the same as the analyze here, headers, yeah, comment, body, request, comment, body. Okay, so for the create symbol beam here, this one you can see that I have a lot of dictionary. So this dictionary is um, this one. So response, body, and IJK, this is the basic stuff. And this one, TIC main 1, sub 1, sub 2, sub 3, sub 4, design, stiff, steel box, and custom PSC. This one is basically like this one is basically like a tier. So you can see here, For example, this one is a structure group. You can see that there are a tier like this one. This is one line, line 2, line 3, and line 4, right? So this one is considered as DIC main. This one is considered as DIC sub 1, sub 2, sub 3, and DIC main, DIC sub 1, sub 2, and sub 3. Okay. Okay, let me show you in the PowerPoint. Okay, so you can see here, this is the API in the Visual Basic. So previously, you can see that the new file is only this one, the analyze is only this one, so this one is quite basic. But for the create in the dictionary, Visual Basic, you can see that because this one is just a declaration, so you can actually create a dim DIC main and sub 1, sub 2 until sub 20, but you only use maybe main, sub 1, sub 2, sub 3, it's okay. You can declare as much as you want, but you can use something that not all of things, okay, but it will make the response time longer. Okay, okay, so this is the an example for creating a unit body. So this one is the db/unit, the same as the Postman. Okay, so you can see this is the JSON for the unit. So you can see this one is the first line, second line, and third line. So that's why this is assigned to be DIC main 1 for the first line, DIC sub 2 for the second line, DIC sub 1 for the second line, and sub 2 for the third line. Okay, so that's why in here in the create unit body, I set the DIC main as a new dictionary, DIC sub 1 as a new dictionary, and DIC sub 2 as a new dictionary. And then if JSON starts from the top line, so it means that its assigned is the DIC main 1 is DIC sub 2, sorry, 1 is DIC sub 1, and forces, distance, heat, and temperature is DIC sub 2. In the Visual Basic, it starts from the last thing. So you can see it starts from the DIC sub 2 first, dot add distance, comma dist, and the DIC sub 2 dot add forces, comma force. Okay. Okay. So you may know that when I first start with the DIC sub 2 dot add here and quotation mark dist question quotation mark comma dist, this dist quotation mark is this one. Okay, so dist quotation mark is the data that is in the JSON. So you cannot change anything from here, dist here. But in the second one, you can change this one, because if you see in the dictionary here, you can see in the dim dist as string. So if you change the dim dist, maybe dim distance as string, if you change this one to distance, you have to change this dist as distance. Okay, so you have to make this distance and distance as the same one. So you need to be consistent with each other. As well as the force here, comma force. Force is the same as this one. Okay, yeah. And for the DIC sub 1 dot add, comma 1, comma DIC sub 2. So this DIC sub 1 dot add, this one is referring to this one, but because this DIC sub 2 is within the DIC sub 1, so you can see that this DIC sub 2 is in the below the tier of DIC sub 1. That's why it needs to have DIC sub 2 sub 1 dot add quotation mark 1 comma DIC sub 2. So this is just to show you that the DIC sub 1 is below the DIC sub 2. That's why you can also see that in the DIC main dot add quotation mark assign quotation mark comma DIC sub 1. So it means that the DIC sub 1 is within DIC sub 1 is within the DIC main. Okay. Okay, so after that you can just the same as the last one. You create a body equals JSON converter dot convert to JSON DIC main, response equals web request, and this is the comment, this is the response, and comma body, and then debug print response here. And then after you use the dictionary, you can just set DIC main to nothing, set DIC sub 1 as nothing, and set DIC sub 2 as nothing. Okay. So yeah. So you can see in the material body, because they have a lot of dictionary, you can see they create the DIC main 1, sub 1, sub 2, and sub 3. So in the material body and material body, they have another tier in here. Okay, you can see that this one, I create a dictionary for the distance here as string, dist, force as string, forc, and you can also see that I use dist and dist as well to refer to the cell that is in the value. So this distance is the value of the distance is in E5. So if you see in the E5 here, E5, this one. Okay. And you may also know that in the E5 there are drop-down menu like this. So how do I use this? So this is located in the data validation here. So if you click on the data validation, you can change the value that is in the drop-down menu here. Meter, centimeter, millimeter, inch, and feet here. The same as the force here. Kilonewton, Newton, kilogram force, ton force, pound force in chips. Okay. We also create for the DB S235 here. Okay. So actually you can create your own data validation for standard here, but you have to be sure, because if you select maybe a standard of CNS, for example, but you use database for EN05S, that will be wrong. Okay, so you need to be careful about that. This one is a loading, and this one is load case. Okay, so we go back to, okay, so this one, we create this one because this one is basic. So to create the classes from the IC main 1 until this is sub 5 here, and then actually we can create until this is sub 6, sub 7, sub 8, sub 7, sub 9 is okay, but I just create this one to differentiate between each other, because this main until sub 5 is within one request. So maybe if I have maybe a construction stage with maybe a 3-tier or 4-tier, I can use main, sub 1, sub 2, sub 3 here. But if I want to use maybe specifically for DIC design, or maybe yeah, I want to use something, some request that is exclusive, maybe I can use DIC design. I will show you later. Okay, so here this one is a dimension for only input data for sheets. So you can create an information. So if you type a string, for example, you can just type here, type this apostrophe, one apostrophe, and then type anything. This will be considered as a comment, so it is not considered as a script. Okay, so this one is for distance, force, length here. Double means that it's just a large number, and variant here. Variant is just if you have maybe a cell, maybe maybe if you have a row and yeah. So maybe if you have an x and y direction, you can use variant here. Direction, string, double, range here, model ID, load case, mat st. Okay, I will. Okay, so uh, distance is force is this one, and y bar z bar is this one, and the XLS steel box is this one, because the steel box is this, and it needs the B1, B2, B3, B4, B5 until etc. here, and XLS custom PSC is this one. Yeah, the direction is the string is this one. Yeah, with model ID. So you can see this one is the distance and force of E5 and E6, and the length is in E8 here, E8. With the XLS steel box is the range here, you can see E9 until E21, so here. And the Y bar is only this one, and Z bar here. The section IDL, IDM, IDR is that just the section ID for the section, because okay, maybe I will show you the results of this one first. Okay, so when I copy this map key, okay, and I copy the URL, I'm sure the URL is the same, but I just want to be safe. Okay, so when I click new file, it will create a new here. And then I want to create the PSC. Okay, so you can see that the nodes is created, the element is created thanks to the length here and the direction, yeah, the length, and then the material is created from this one with this one material concrete here, S235 is EN05S, right? And the section, you can see here, I have two sections. The first section, is the section on top here. Section, sorry, the first section is the section at the bottom. You can see here, this is the steel box, center top here, and this one is the section for the top PSC here with the center bottom. Okay. So how do I change the center top and center bottom? This one is currently still in the the vis the Visual Basic data. Okay. So when you see, yeah, this one. So this one is to create the section 1. Section 1 means that it will create the one with the center top, right? The center top offset. So when I use here, create section 1, I create this one. This one is just basic stuff to create this one, to add the P1, P2 until top here. And I set the property for section 1 with the v size array here. And this one is a sub 4, so sub 4 means that this is in the last tier. And you can see in the sub 3, I create the offset PT of CT here. I can create this the offset within the Visual Basic, or I can maybe refer this data into this file. So maybe if I refer this one to, maybe I um, created an offset 1, and then I add offset 1 in here. So maybe I declare an offset 1 equals cells something, cells 13H, value. And maybe I add another one, offset 2 equals cells 14, H dot value. Okay, and don't forget, so you can see when I click direction here, I have declared the direction as well, dim direction as string. So if I create offset here, I will also have to declare the offset as string, because the offset will be a string as well. Okay, so I have declared offset. I have given the offset location here. So maybe this one offset 1 and this one is offset 2. Okay. Okay. H13 and H14. And in the section property 1, I can add this one. So after DIC sub 3, offset PT can refer to offset 1 here. Okay, so this is the same as this one. So DIC sub 3 dot add standard comma MATST, because MATST is already declared in this one. MATST equals cells 5L, and also MATST equals string in here. So you already declared in here. You already declared the data will be in cell L5, and then you can refer the MATST to the calculation of the material body. Okay. So in this case, for section 1, it will be center top. So this one will be CT. And this one will be center bottom, offset 2, CB. So we can section 2. Which one is section 2? Oh yeah, this one. This one is for creating section 2 here. Section 2. Okay. This one vertex data x and data y is just the coordinates for the PSC here. This is only to build vertex design. this one, CB. So this one will be offset 2. Okay. Okay, then I save this one, and if I create a new file, okay. So you can see that the section 1 is still having the center top, and section 2 is still having center bottom here. Okay. So that's just like the the example of how to assign something and creating an example, creating an example from data input from the Excel, and that can be used to be combined with the script that you are creating from Visual Basic. Okay. Okay, so maybe we go back to, because this one is creating the section ID, right? And maybe I will show you the JSON manual for Civil NX for section property, section property for PSC, for example. Oh no, PSC value. Okay. Okay, so this PSC value is the section 2. Okay. Okay, so that's why in the section 2 here, if you can see, this one is a main 1, main, sub 1, sub 2, sub 3, and sub 4. Yeah. Yeah, sub 4. And so I don't create any. Okay, so maybe the vertex will be sub 5, but in this case I created the DIC main sub 1, sub 2, sub 3, sub 4, and then I create the DIC design. And you can ignore this DIC stiff because I ended up not using this one. Okay, so we are going to the last thing first. So this is vertex. So vertex is just the coordinates that we will be using for the PSC. So if you remember in the Excel, I show you here. This is the vertex for the coordinates. They will ask you about the outer polygon and inner polygon here. But in this case, we only use the outer polygon because this PSC is not actually having a box here. So you only need one outer and 0 inner here. So that's why I only use outer polygon. There is no inner polygon in here. Okay, so in here you can see that the outer polygon vertices here, list of point, I want to declare the vertex data x as variant, vertex data y as variant, so xy here, and then outer polygon as collection, set outer polygon as new collection, so dim and then set, and dim and then set, and dim and then set here. Vertices as collection, and polygon 1 as selection, as dictionary. So you can see I declare the vertex data x as the sheet 1 dot range from J19 to J70. So this J19 to J70 is just this one, from J19 to J70, and then K19 to K70 here. Okay, and then I want to build the vertex array. So this build the vertex array is for I to U bound here, and then set pt to create object here, and then pt at x dot comma vertex data x I comma 1, and px data y is I comma 1, vertex at pt and next I. And then I use the polygon 1 dot add vertex vertices because I already created this one from vertex data x and vertex data y. It means that I only need to use this code, and then I just add the number of the data from this range, and then it is it is uh, it is correct because you already seen that the Civil NX can read this polygon data, right? So if you can properties here, you can click define by coordinates. You can see the coordinates is the same as the one that is sent in the Excel. Okay, so to yeah, and then here, and then this one we don't need this one, and because why we don't need this one? Because this area ASY, ASZ, RXX, RYY is automatically calculated by you creating the coordinates. So when you creating the coordinates, it will automatically calculate this area here. Okay, and okay, so this one is a Y bar and Z bar here, and then for the sub 4 is starting from the sec type, so this one here is starting from the here sub 3, offset pt here, offset center until sec I here, shape value here, and then for the sub 2, this will be sec type, sec name, and sec before here, and sub 1 is the ID. And you can see that in the ID, I don't create just number 1 in here because I assign this sec IDM in here. Because if you remember, the I have section ID for left, middle, and right here. So this is to assign which uh, which element has which sections. So in the Civil NX, you can see that in the 7, 7 here. 7 here. This is the bottom's nodes, right? The bottom nodes has the left and right with the section ID is the same, 7 and 7 here, and the middle has the section ID of 9. That's why it's this one. Okay, and I also assigned the section name as this one. Section 1 name is this. Section 2 name is this one. Okay, yeah. So this one is to create the section ID, and then this one is to create the node body. So node body, this is just looping to create the nodes. So this is just a simple division. So you have the number of division as long here. This is yeah, number of division is created by our own. So for example, if you have a length of 10 meter here, 10 meter divided by num division, so it means that you will have 2 meters per each span. So per each nodes you have 2 meter. So this to this is 2, this is 4, 6, 8 and 10 and whatsoever. Yeah. So you can obviously you can change this one, the number of division. And then I go to create the loop to create nodes here. For I equals 0 to num division, so 0 until 5 here. So it will only have 5 nodes, 5 division. I will have x equals I times interval. So the division 1 is only division 1 times the interval. Interval is just the length divided by num division. So if the interval will be 2 meter, so the division 1 will be 2 meter and division 2 will be 2 times 2, and then division 3 will be 3 times 2, and division 4 will be 4 times 2, and division 5 will be 5 times 2 equals 10. And in the y and z we use stagnant. So if you want to use curve, you can do so by changing the y to becomes an interval. So maybe you can also change the y to I times interval, or maybe I times something divided by something. So if you want to have specific range, you can do it in here in the y direction and z direction as well. And in here, yeah, this one is the same. This is just to add the model ID 1, 3, 1 plus I, and the IC sub 2. So this is just to create the nodes here. So if you go to the node creation, yeah, so this one is the I, X, and Y. So this one, you can see the IC sub 1 dot add model ID 1, 3, 1 here, plus 1, comma the IC sub 2. So yeah, this is just to create the model ID. So this is only for model ID 1, and you can see that this is for model ID 2 here, and I want to create for model ID 3. So why do I do this? Um, because I have a model ID for the left, middle, and right. So if I only use this one, so if I only use the num division for only model ID 1 here, it means that it's only created for the left. So the model ID for the middle and right is not created. Yeah, so you can see here when I assign the set model ID 1 here, I set the model ID range for E25 until E28. So you can see E25 until E28. So when I say set model ID 3,1, it means that 1, 2, 3. So this is starting from node 13 here. So the left side is starting from node 13. So when you click, when you see uh, the node here, you can see this one is starting from 13. This is starting from 7. This is starting from 1. So starting from 13, 7, and 1. Yeah, that is for creating nodes. And now we create elements body. So this is just the same. Just use the type here and material using model ID 1. So you can see my model ID 1, 1, 1, it means that this is from here. Section model ID 2, 1, so 1, 2. So this is the section 7. And nodes is the array from model ID 3, 1 here until model ID 3, 1 plus I plus 1. So this is just to looping from the first node to the second node. So if you only use model ID 3, 1 plus 1, it means that you only have one node, but you cannot do it because creating elements needs two nodes. So that's why I have two nodes. The first one is the first node, and the second one is the model ID 3, 1 plus I plus 1. Yeah, so it's like just starting from element set 1, starting from node 13 to node 14. Yeah, and going through. So you can see the naming of that element is in here. The IC sub 1 dot add model ID 1 4, 1. So 1, 2, 3, 4. So this is starting from element 1 plus I. So it will going forward until the last one. So if you click on here, you can see that in the right side it is start from 1, 2, 3, 4, 5 here, and then for the next one starting from 6, 7, 8, 9, 10, and for the left, the right is starting from 11, 12, 13, 14, 15. Yeah, this is element body for number 3, right? This is for number 2, and this is for number 1. Yeah, and this one is just basic to create boundary body. Yeah, so this is basically the same as the JSON. So the first one is to add the assign and then model ID and then items constraint here, and then model ID again, item constraint ID. Yeah, yeah, it's basically the same as the JSON for the boundary, and this one is for also for load case. So if you are maybe a little bit confused, you can use ChatGPT to alleviate this one. So maybe if you use ChatGPT, for example, maybe if you if you have a maybe this one. Can you convert this JSON into VB net format similar to this? So maybe you gave some of the choices, maybe. Yeah, you can see that they will all automatically show you the maybe the choices to create a vertex like this, the IC main, outer polygon, inner polygon here. So you can see that they first create a vertex here, but because you have the data is provided from the Excel, that's why this data is provided in the VBNet. So you may as well use my code to correct it. Yeah, because you can see that in the vertex here, if you compare to mine, when you create the section in here, yep, in here you can see that the DIC main is correct here, but the outer polygon, you can see the outer polygon I dim the vertex data x here, y, and they dim the outer y as new dictionary, and outer one dot add vertex array here. But mine is vertex data x sheet range J19 to J70 because my data is already in the Excel, and then after that I built my own data from here. But in the ChatGPT they just show you the basic stuff, because if you can see, the basic stuff is this one, v size array in outer and inner polygon, and then the IC sec before offset PT, this one is the same as this one, and shear check is this one, sec type is this one, calculation option here. Yeah, so you may as well use my example here in the build the vertex array here. Yeah, you can also use ChatGPT to improve your own coding. So maybe if you have my code in here, and you can just copy this and you can ask ChatGPT to explain the code here. I'm sure that the ChatGPT will explain it better. Um, yeah, to be more understandable. Yeah. Okay. Yeah, so yeah, it's basically the same. So starting the load case here and creating the self weight as well. The same as the JSON code here to create the LC name here. Yeah. And you can also, so remember, if you want to input the data yourself in the Excel, you can do as I said before, just change the offset, maybe change the offset and then create uh, you can change the offset here, you can create the offset here and then declare your offset creation in here, offset value, this is the number, the cell location, and then create the dim offset 2 here, so that the system will know from where the data will be taken away. Okay. Okay, that is for Excel VBA. Yeah. So all of the data is already given for you, the Excel VBA here to be, so for you to maybe reverse engineer some stuff to adapt to your own project. Yeah. So I have given you the basic stuff, and you can explore it on your own. Yeah, and this one as well for the GPT prompt. Uh, you can create. So for example, this one. So usually I use GPT to convert convert the code from the MATLAB code to VBA code, or maybe to from VBA code into from JSON to VBA code. But maybe you can add another prompt, because previously when I show you the GPT prompt here, I only give some basic stuff in here, because I only ask them to, can you convert this JSON into VB node format similar to this, but I need to give more prompt. Maybe, oh, I I have I need to have the data taken from Excel, maybe. So please, so maybe the prompt should be like this. Can you convert this JSON into VB format similar to this, but keep in mind that the data from vertex X and Y needs to be taken from cells in Excel, um, also give the web request script from the beginning, which contains MAPI key and base URL and content type, give correct format, maybe like this. So the more complicated prompt that you gave, the more uh, yeah, the more complicated their answer, because you can see they will assume something and they will give you the actual assumption here. So you can see, oh, for example, if they assume that they have 8 outer points and 6 inner points, and they use the range here, yeah, it means that, yeah, you know what they're assuming and what can you do from that. Or maybe if you are not, maybe needs to have more explanation, you can just copy this and maybe as explain this. So here you can see that vertex data x is starting a loop from one number of the row. So it means that with this one, they will create a loop from one row to the other to fill each of the data seen here. Okay, U bound. U bound is the gives the last row index here. Yeah, DPTS object here. Yeah, like this. Yeah, they will also give you example in practice. Yeah, so okay, so thank you very much for watching this video, and if you have any question, you can just click here for support Midas user. Here API manual. You can also see our website in midasuser.com.tw here, and you can also email me at michael@midasuser.com.tw. Okay. Okay. Thank you. Goodbye.